practicing your build? Write that in your notes, please. The word is integration. Write that in your notes. The word is integration. That in your notes. The word is integration. Okay, so we will be studying in this whole unit is about integration. In fact, calculus really can be divided into two major topics, differentiation and integration. We've studied the first topic, we will now study the second for the rest of the year. So, but to study integration, we've got to kind of pick up a few associated things kind of along the way. So, write this on your paper as well, just a little formula. The formula is x of t is going to equal 1/3 t cubed minus 4 times t plus 1. Okay, so that's just an equation that describes something. Integration is just the topic for the entire rest of the year. So we won't specifically talk about integration today. We're just kind of building towards it. Okay. This formula, you've seen this before. Somebody earned some tickets. Raise your hand and tell me when you see a formula that says x of t, what does it represent? All who know, actually, all who know. What is the formula representing when you see a formula that says x of t? This is one of your flashcard facts. This could be on a quiz someday, okay? You've got to know this. Let's go, Jacob.
It's 1 over 2t simply minus 4t plus 1.
Good answer, 2 tickets. Definitely x of t is exactly the same thing as this equation. It's a good answer. Symbolically, what does x of t represent? Symbolically. So Seth? Perfect. So the x of t is saying the position of a particle at some time. How many knew that? 2 and 3%. Okay. So that's one of the flashcard facts. X of t means position. Okay, next thing. X of t specifically refers to a particle that is moving horizontally. That's why they chose the letter x. So look at my marker. It's a particle that moves just like this, back and forth. Okay, the particle does not move this way, and it doesn't have complex motion, meaning kind of both up and down and left and right. The particle only moves left and right when they say that the position is given by x of t. Give me 1 or 2 fingers if that makes sense. 1 means perfect sense, 2 means it doesn't make sense. Like what the symbol means. 1 or 2. Give yourself 2 tickets. There were a couple who were just a little foggy. If you can kind of, you know, you just say it again, or say give a different example. You have a question you could ask, please.
So that it doesn't move up and down at all.
At all.
It's a perfect straight line.
It's a perfect straight line. Now you can picture the straight line in a lot of different ways if you want. Like you can think of it as really x of t is going to represent my position as I simply walk back and forth.
Oh.
So I'm walking only in like basically 2 directions, I guess, but 1 dimension. Like just back, please.
So that's just like when it says x of t, or is that because of the equation itself?
Perfect. Hey, 3 for Oakley and Ellie. Those are good questions. It's not because of the equation, it's simply because of the symbol.
So it could be t squared minus.
Yeah, the equation could be anything. And it would still, if this says x of t, this could be anything you want. Because this says x of t, it represents a particle moving just back and forth. Other examples I've seen on the AP test, Ellie, is they'll say a car moves down a road, a straight road. They would represent that possibly by the formula x of t. I saw one that said a guy's on a unicycle on a road. He rides back and forth. He doesn't go any other direction, just back and forth. That would be represented by x of t. Does that help? Please, Sarah, question.
So like the graph.
Nice. The graph's not going to be just back and forth. We'll show that in a second. But what's important is to remember the motion itself, the actual motion is just back and forth. Good with that? Cool. Give me one or two if it makes perfect sense. Show me, come on. One or two if it makes perfect sense. One or two. Two more tickets, good work. Okay, so by contrast, Ellie, since you asked such a good question, two more tickets for you. They could give you a formula called y of t, and it could be anything as well. Like it might even be some sort of trig function. Like that, it could be anything. But if they say y of t, they are no longer describing motion that is like this. Kelsey, what are they describing? Up and down. But still, Kelsey, not up and down like this up and down, but like this up and down, straight up and down.
So it's gonna, all the questions are gonna say the line and everything, we're not doing anything.
Nothing that moves in a complex way. So here's some examples. So x of t, the examples I've seen that would be kind of x of t would be, again, a guy in a unicycle riding back and forth. I've seen a car moving down a straight road, has a certain position, just in a straight line. They often say a particle moves back and forth along the x-axis. When they say x-axis, they don't really mean x-axis. They just mean a line. It's not the x-axis on a graph, it's just a line. Are you with me? Okay, up and down, here's some examples. They'll say someone drops an object and it just falls, but it falls straight. It doesn't fall like this. Okay, just the problems we deal with are just straight. So x of t is always back and forth, straight. Y of t is always up and down, straight. I've seen ones that say a balloon goes up and down. They don't depict a picture of a balloon floating like this. It just goes up, it goes back down. There was one that talked about a river bank. And as the river water rises, the bank of the river, like where the water is, right, moves inland. Make sense? But it's moving in a straight line. It's just a straight motion of the water. So, other questions, please?
Will we ever deal with it like one movement?
No, not for our class. No. Anybody else? Perfect. I'm going to erase this one because I don't really need it, but that's the idea so far. Good. Okay, we've got to get proficient on the calculator, so I'm going to show you several things with the calculator today. A bunch of stuff you know already, but sometimes you forget. And then I did notice last week there were several things people didn't know. So here we go. We want to plot this. So on your calculator, if you have an Inspire, I do not have the software currently loaded to demonstrate the Inspire. Most people don't have an Inspire, and if you do, you usually can find somebody else in the room who can help you, or I can walk over and help you. I just don't have it up here. For an 84, 83, or 84 color, you just hit y equals. Okay, this is going to get plotted on the y-axis. Then the x-axis will represent time. Let me show you a feature of the calculator. Notice how my calculator says 1/3. Raise your hand if you know how to make your calculator do that. Okay, that's what I thought. Most people don't know. So here's how. Watch. You have an 84. This will not work on the 83. Only the 84. Sorry. You hit alpha. Hit alpha. And then you're going to hit the F1 key, which is y equals. You get a menu. It's just a bunch of different fractional representations. We just need the first one, just a simple fraction. So press enter and you're all set. Wow. Raise your hand if you got that to work, please. Show me your hands. Dope. 2 more tickets. Good. Alpha F1. Oh, okay, so nothing happens. Okay, does anyone have an 84 and it did not work? So you go to Jeff stretching. So Brady doesn't work, and so hold on, let's fix this. Anyone else besides Brady and Sarah? So give me yours, Brady. Hold on a second.
Hey.
Is this one? Is this one? You just pressed it.
Can you back up my friend? What you're saying, what you
Thanks, Phil. You want to see it anyway? I would want to see it, right? You know why it goes?
Spent my calculator just died.
Look, ready? So we're putting it in, right? It's a third. So, that's going You already know that? Nobody else in class knows that. Good job,
Look at me. Okay, so just so you know, if you have an 84, okay, you're going to always use this. Please, look at me. If you have a fraction, use this. It prevents errors. When you start using parentheses, it gets really confusing. If you have an 83, you have no choice. You just have to use the parentheses. Now, look, I'm not recommending anyone buy a new calculator. If you have an 84, an 83, or an Inspire, will do everything you need to get a 5 on the AP test. Okay? If, however, you find yourself getting frustrated with an 83, if you love calculators, you like to push buttons, you like to go through lots and lots of menus, then you probably like the Inspire. If you get frustrated by having to learn a whole bunch of different keystrokes and menus and commands and things, don't buy an Inspire. Buy an 84 color. Okay, an 84 color is my choice. If I were to buy a new calculator for my kids, I'd buy an 84 color. Josh, not for Chris. It's up to you. It's kind of a, depends on how much money you have, I guess.
doesn't make calculators.
The 83, okay, look, here are the disadvantages. Santa doesn't make calculators. 83, hey, Derek, look up. The 83 won't do the fractions. You have to use parentheses, which can cause confusion. The 83 won't do this either. Eventually, we're going to use this feature, Math 8. Okay.
You're kidding.
83, listen, hey. Quiet. Listen. The 83 does this, it just doesn't look like this. So it's a little harder to just remember what you're supposed to type in. It's not bad. Like I had many people get 5s with an 83. Okay? Just have to learn to use it properly. The 83 also won't do this symbol.
Oh my gosh.
Again, it just does it in words. So you just have to learn. So those are the trade-offs. Those are the trade-offs.
I have a question.
Please.
Can I use the Inspire on the test, or would I have to use one of these ones?
No, the Inspire is allowed on the test, but it's what I told you. They write their problems in such a way that having the Inspire is no advantage.
Okay.
So, but you can
So,
use it.
yeah, if I could, yeah, if I couldn't have.
No, it's legal, it's legal.
Okay.
Are both versions of the Inspire?
Yes, yeah, it's not like the ACT, so.
Yeah.
The problems are written, what happens is there's a non-calculator section of the AP test and a calculator section. So having the things that the Inspire can do doesn't help you because it's not allowed on that section of the test. And on the section of the test where it is allowed, they just don't ask those kinds of things, so it doesn't matter. Anybody have a question about calculators?
Yeah, can you do that as that one here?
Uh-huh. It's simply math. 8 will not find the derivative of a function. It simply will find the value of the derivative at a point. Again, useful on the calculator section, but we learned everything we did during semester 1 because you still have to take the non-calculator section of the test.
Oh.
The non-calculator section is about 2/3 of the AP test. So.
Oh, sweet. Nice.
Please.
Maybe this is like the license of
Yeah, real quick.
He looks like.
Look up. The format changed a tiny bit this year. So later, I have said it wrong, I apologize. I think I've got it memorized, the new format. The first section of the test has 30 questions. They're all multiple choice. There are 4 answers per question, A, B, C, and D. And there are 30 of them. So you have on average 2 minutes per question. Now you won't practice the AP test that way. That's not how we practice. We practice by doing the easy questions first and working towards the hard ones. Because the easy ones count exactly the same as the hard ones. Got it? Good. Then you take a short, it's not a break really, you just kind of like close the booklet, seal it up or whatever, and then they let you take out your calculator and you get 45 minutes to work on 15 questions. Okay.
Oh, so they're gonna be hard.
They're not, they really aren't. In many, many years, hey, it varies from test to test, but I would say in recent history, most people have found the calculator section to be like much easier than the non-calculator, even though they give you more time. I don't know why they do that. I don't know if it's just because of how I teach, it just makes it easier, I'm not sure.
Is it weighted the same?
Weighted the same, yep. So the 15 questions in the calculator section are worth no more than the 30 that are in the non-calculator section. Just for some reason, they give you 3 minutes on average instead of 2. One person's theory was that because you have to type things in your calculator, they're kind of giving you time to do that. I don't know, most people in past years have found that to be the easy section. Then you'll take a break. You'll come to the cafeteria or the patio if it's nice weather, and I'll have like Costco on display.
Yes. I've heard of Costco on display.
Costco on display. You have to elevate your blood sugar. It's a fact. If your blood sugar starts to drop, your brain does not work as well. Okay, so I can give you some sugar. I do. I give you some sugar drinks and some snacks and things to get your blood sugar moving. I have some fruit juice and stuff, whatever. Something's got to have some real, it's got sugar in it. Okay, either natural or refined.
Calories.
You need some calories. You do to make your brain work better. It's been studied. If you don't get it, your brain it drops. So you take the short break. It's like 10, 15 minutes. You go back.
No.
Then you take 30 minutes to do 2 free response questions, but a free response question really has typically parts A, B, C, and D. You're working on kind of 8 separate little questions that are kind of related with your calculator again for 30 minutes. And you close up that book. No, you don't actually close it. Then you put your calculator away and you spend 60 minutes working on 4 FRQs. Each of those have typically parts A, B, C, and D, so it's really like 16 questions. Quiet. As you are working on those questions, if you decide you want to go back and work on the first 2 FRQs, it's legal. You just don't get to use your calculator anymore. Does everybody understand? Okay.
Can you work ahead or not?
No.
Against the law.
Against the law. Yeah, if you work ahead, your test is voided, they let you leave the room. So they They escort you from the room, is a better word to say.
How long total you had?
So the testing time is 3 hours and 15 minutes. The time that you're in the room is 3 hours of actual testing, 3 hours and 15 minutes of actual testing time. Plus break, plus paperwork, plus whatever. Usually what you do is you line up at the door at 7:30 in the morning, because there's a lot of people that have to be seated in the maroon gym. And then you get back to my room where Costco's on display again, at about 1:45.
Oh my gosh.
So,
I'm just not even.
it's good preparation for college. Right now, BYU is in the midst of their finals.
Mr. Smith, do you have Oakley Becker?
Yep.
Please send us anything checked out. Thank you.
Yeah, BYU's in the middle of finals week. This gives you a good sense of what a real final is like. It's not like a high school final. This is what a real final is like. Real life. Real life. Real college.
Real life?
About that.
Yeah.
Okay. Like,
This last night, right?
formulas.
Have fun, dude.
So like,
Good luck.
right, so you guys are more how to think about, not the formula. There's your board. I'll show you later. We'll do it.
Peace, bro.
When's it gonna be out ready to watch?
Quiet.
In a couple months. It's like a piece.
Okay, look. So, get the formula typed in. Get the formula typed in, please. Get that typed in. Raise your hand when you have it typed in, please.
So fast.
Do you want to take it? Hey. Raise your hand if you've used the Zoom Fit feature. Okay, everyone wants to know this. The most useful Zoom feature in calculus is the Zoom Fit. So the first key you press is Window. Now you can do this on Inspire as well, just the keystrokes are different. So you're going to find the menu that opens up the window. So you go to Window. Okay. When we're dealing with the position of a particle, someone can answer this. X means time in our case. What time do we want to start with? Pretty much always. What is that here? What? 0. That's 2 for Kelsey. Okay, look. Look at me. Okay, I've done hundreds and hundreds of AP problems. In many AP problems, they'll give some information so I know what to set the minimum time and the maximum time to be. If they don't, 0 time for minimum is a good choice. For maximum, 5 is a good choice. It may not work perfectly, but for many, many problems, it's a good start. So put 5. Then you press the Zoom key. Again, on the Inspire, it's a different menu sequence, but the same idea. Press the Zoom key. You want to find item 10 on the menu, item 10. So it's way down here. But I'm never going to scroll until, again, I'll show you once, but I won't scroll again. I just press 0, so it's quicker. I just press Zoom 0. It does. It's the 10th item on the list, Sarah. So I just press Zoom 0 and it graphs it perfectly. No, just Zoom 0. That's it. Don't press graph. Yeah, E3 is. Sorry. You like this stuff? This kid stood up in my religious services, and he said, last Sunday, the first Sunday of the month, you know, okay, he stands up and he goes, we've been doing service, he's like 14, he's like, we've been doing service projects, and I really thought it was stupid. He's like, but after helping out this one family for a while, I'm getting a pretty good feeling. But he's honest. He says, and plus it's really good we help them because they're sick and old. Everyone kind of goes, all right. Hey, would you have this on your screen? Show me your hands. Show me your hands. Show me your hands. Who has this on their screen?
Booyah.
Your hand is raised. Give yourself 2 tickets. You need help. Next on the list. Yes.
So I can't figure out how to get to there.
Oh, no worries. Anyone else have an Inspire? Put your hands. Anyone else have an Inspire? Did you get yours to
I
work?
do,
Oh,
but
I don't know.
I think mine's good.
So you guys are just staring at me.
No, I'm just doing Heidi's.
Oh, okay.
Oh, boy. Got it. No, it's a boxing. Not fighting. Roll the bell. Yep. Just kidding. I just need to Whoa! What are you doing? That's down. That's my question. I didn't do anything.
Hey, quiet. Look at me. Anyone besides Lexi who's got a dead battery? Anyone not working? Oh,
He's working with me, but yeah, I'm dead.
does it still work? Oh, yours is dead too.
Not dead. It just has no. It doesn't have any batteries.
I'm not that.
That doesn't. Just the extra juice is flowing. See, you got fired. No. All right. 2 seconds.
Color is better. That's a higher resolution display and it's colored, so it's just easier to see. That's otherwise the same. Who's dead? Who's dead? Make sure you give that back.
I honestly think tomorrow everyone will be late. Everyone should be I don't be charged. It'll be my nice. I calculated it. It's easy all the time. I printed it. It was like a new typewriter. And then I couldn't find it. What? There it is. What? Yours is I hate you. Hurts. Girlfriend and that.
Look at me. Okay, quick story. Look at me. Quiet. Silence. Good man. Thank you. Lexi, look up. Breathe. This is mine. Okay. Got him. Could not resist.
That deserves a dab.
Oh, thank you.
I'll fall over again. He just got surprised.
Silence. Good story. Listen close. Okay. Now, Erica and Paris are, look, they're running into some common problems. And I'm going to show all of you how to fix what they're running into. So listen to the story first. Here's the motivation for listening to what I'm about to tell you. I had a student one year, about 4 or 5 years ago. Okay, I heard this from her friend. Okay, they're taking the AP test in the maroon gym. Okay, they're taking the test. They're in the midst of the calculator section of the test. This student told me she looks kind of noticed off to the corner of her eye that her friend that's a couple of desks up is literally crying. Look at me. Listen, listen. Here's why. Listen. Hey, hi. Here's why. Okay. The student who was crying had done everything really she needed to do to be very, very ready for the test. Like very ready. Like she attended, and she knew from the practice tests that we take that she really, all she had to do is show up, do what she'd always done, she'd get a 4 easy. She just knew it. Okay? So she was well prepared. Okay, but partway through the test, what's happening to Paris's calculator and what's happening to Erica's kind of happened to her. Listen, listen, listen. It can happen to anybody. It's going to show you how to fix it. It's really not hard. Okay, you just got to know how. Listen. Now, the good news is the student who was having trouble calmed down. She kind of remembered she got it fixed herself, and she got a 4. Okay, so watch what you do. This is not true of the Inspired. If you have an Inspired and things go bad, you should probably turn it over and press the reset button. Okay, serious. Just start fresh. Start fresh. Okay, but on the 84 or 83, here's what you do. First, you find the pen, which I set down somewhere.
It's in the wall.
So find the pen. Keep
In
looking.
your pocket?
Thank you. All right.
Good eye.
All right.
Wait, did you know it was in there and you were
I
just
did
like
not.
testing us?
I'm actually not very good at that. Like, I'm just a very honest, upfront person, so I'm not good at fooling you. I try, but I just don't. All right. So that was legit. I just lost track. So hit Y equals, please. Everyone hit Y equals. Hit Y equal. Press the arrow key until the plot 1 is highlighted. Okay, now press enter. You should see a difference in the highlighting.
Yeah.
Now press down arrow and you should note that plot 1 remains highlighted.
Uh-oh.
Show me your hands if you got that to work. Show me your hands if you got that to work.
Yeah.
2 more, okay? Anyone have a question? Hands down. Anyone have a question? Okay, now look. Now press graph. And watch what happens. Error. Error.
Invalid dimension.
Press graph.
Damn,
How many got the error message? Show me your hands.
No.
Show me your hands if you got the error message. Show me your hands. Who got the error message?
2 tickets.
More tickets. Okay. Watch me. Hey, watch. Watch. So it says error and it has only one option, which is to quit. So just enter. No.
Give up on the test. You're done.
You're done.
Oh, silly fool. Okay.
Yeah,
Y equal.
That's way fast.
Y equal. Just go up to the plot key, highlight it, turn it off.
What's the point of highlighting it?
I'll tell you in a second. Now press graph. You have the graph. Show me your hands. Who has the graph working? Show me your hands. Who has the graph working? 2 more tickets. Okay, now here's what happens, Derek. Apologize to me.
No, you're
Issue
good.
of disparaging your marks. Okay. What happens, Derek, is for some reason when you're just typing things in, it seems to be, it's pretty common actually, that you will, without noticing, you'll accidentally put the cursor there, press enter, and then just keep doing things. You don't even notice.
Yeah.
And then you get that error message. So you just got to know that if you did that accidentally, you got to turn it back off.
Well, why is
I have
it
a
there?
question.
What it's there for is this. Hey, 1 second. So this is a statistical feature that gets used for statistical type questions we don't deal with. And all the stuff that's needed to make the feature work isn't loaded in the calculator. So it's just saying, I don't know what to do. That's all. Heidi, please.
So if something bad happens on your calculator and you don't know what's wrong, then the 84s or 83s you set it to.
Next thing I'll show you.
Throw it on the wall.
So what Erica's got on hers is she's got some stuff loaded that's just getting in her way. Look. I've seen people just like simply loan it to their brother or sister or a friend. When it comes back, like, Mr. Smith, I don't know what to do. It's like they did something. Okay, here's what you do to fix it. Everyone do this, please. Hit second.
Oh, yeah, we do this.
Memory. Memory is the plus key. Second memory. You're then going to choose the reset option, which is 7.
1. Oh.
You're going to choose to reset all RAM, which is 1. Sorry, Jacob, what's that?
Do we want to do that now?
Yeah, I would do it. Just do it. Unless you have some special program load that you don't want cleared. But most people don't. Yeah, the calculator's fine. All you're doing, Jackson, is some people who are really into calculators will get on the internet and they'll find these software programs they can load into their calculator. This is going to erase all that. I've never had a student. Students who've done that, they know how to run the calculator so well they never need to do this.
Are we allowed to like do that?
It doesn't help. Doesn't help. Been arrested. Everything is my Hey, then you just choose reset number 2. And now your calculator's low, you just bought it. Woohoo! Now if you go y equals Erica, you should look just like this. Type it back in again. Type in the formula. Got it in the window again. Zoom to it.
What's the difference between
What's that? Between what?
So, sorry.
Graph is just commanding it to graph based on whatever the window setting is. Zoom fit, what we do is we set the x value to be what we want, 0, and the other x value what we want, 5. Zoom fit adjusts all the y coordinates. You never have to mess with them.
Are you sure? It's just.
That's what it is.
Hey, you got one in it, I get one. No.
I know I want for Christmas now.
This is good.
Raise your hand if you have this on the screen again, please. Show me it. Come on, Brady.
I got it.
Raise your hand if you have this on the
Brady,
screen.
pay attention. Sorry.
Two more takers. Okay, good. All right, next thing. There's two ways to get values out of this. You should have all done this before, but just in case not, you can hit trace. Okay. As soon as you hit trace, the calculator is waiting for you to tell it where would you like to look. Like you can drive back and forth, but that sometimes is a little bit unhelpful because it picks these really random decimals. It's just following the pixels. So what I prefer often is to actually type in the x value that I want. For example, 0 would be a good place to start. So put a 0 and press enter. I get 0, 1. So let's start labeling what's going on here. So let's see here. One second. Either way, just it's good to know both. It kind of depends when you're doing something. One's not better than the other, it just depends on the problem. That makes sense? So how I did it was this. Back on the calculator, I simply hit the trace key, and then the calculator's waiting for me to do something. So I just type in 0. And that's the x value that's going to jump to. Then I press enter. Please.
One question, I mean, kind of off topic, but not really. So when like we do the window and it's the max, the x, and you're like, based on the question, sometimes it will tell you that when it's like, you're gonna go from like 1 to 5, you know, or like 1 to 8, you know, we're going with it. But if it doesn't give you one, generally 5 is the safest.
Yeah, that's a good start. I'd say 98% of the questions give you information so you'll know the window.
Okay.
And those last 2% that don't, I just go either -5 to 5 or 0 to 5, kind of depending on the question. Raise your hand, this is on your screen, please. Come on, who has this on the screen? Two more. Anyone need help? Help? Anyone need help? Okay, good. we want to make a list here. I'm going to shrink this a little bit smaller so I can make a list. Put this in your notes, please. Make a little table up here. We have time.
Should we schedule?
I would. Put this in your notes, just kind of a quick sketch. Okay, because we're going to start labeling this graph. We're also going to label this table. We're going to label another picture over here. Okay, so far what we know is that if time equals 0, the position of the particle is 1. And that corresponds perfectly to what you see here, that at this point, there's a point on the graph here at x coordinate of 0, y coordinate of 1. That's what we know so far. Question? Okay, we need to remember though that this is not the particle. This is a graph representing the particle's position at different times. It's not the particle, it's not a picture of how the particle moves. It's a graph showing the particle's position at different times. So I want to draw a picture of really what the particle looks like. So on your paper, you're going to draw this. Draw a line. Like so. Okay. We talked earlier, the particle moves in a straight line. Okay, back and forth. If it's easier to think of it, somebody left this nice convenient particle for me here on the floor. Do you know what that is? Yeah, whatever. I'll wash my hands later. Okay, the particle just moves back and forth. That's all it does. So, where should I put something here to correspond to what I've got here and what I've got here? Oh, one other thing. We also need to remember that we could represent it like this. X, when time is equal to 0, is equal to 1. All of these representations, you have to understand them. So how do I make this representation show up down here? Well, because
Would it be at the very beginning of the
not necessarily, but that's okay. 2 tickets. Other ideas? How do I represent this here? Like this is the real particle. It's down here.
Right there. Put it
So
in the middle.
Middle. So let's do this. Let's do this. Let's put a 0 here. Let's ask the whole room. This is a picture of how the particle actually moves. 1 second, Sarah. It's a picture of how the particle actually moves. So raise your hand if you can answer this question. Actually, let's do secret ballot. Does the 0 represent, in this picture of how the particle really moves, is the 0 representing time or position in this picture? 1 means time, 2 means position. Show me what you think. Right or wrong, I'll pay you. Just want to know what you think. In this picture right here of the actual particle's movement, like the floor, this is how the particle moves. Does the 0 represent time, option 1, or 2, position? Kind of a confusing question, apparently. 2 tickets for a good try. It's really position. So what I want to draw is another point here. I want to put the particle right here. There's the particle. I want to indicate that that's where the particle is when time is equal to 0. And that is this position we're calling 1. That's the real particle. Okay, question. Sarah had a question. Sorry.
Oh, well, my question was just like, so can I see you how the positions that how you want it?
Oh, no worries. You good? Okay. Look here, look here, look here, look. This red dot, that is not a particle. It's a drawing of a red dot. Okay? This is the particle. It's like, imagine you could walk out and grab it and hold it. Okay? This is the particle, just like this odd thing on the floor is a particle. Okay? Pretty in fact. All right.
I'll talk to him about that.
Oh, good man. Sometimes it's my fault, because I'm here late a lot, but you know. So I don't want anybody to blame. As soon as they stop by and they're like, oh, and they're like, yeah, there's too many people here. But anyway, appreciate it. Good man.
10 tickets.
10 for Brady. All right. Okay, any questions about the difference? This is a dot on a graph. Every dot on a graph has two numbers associated with it, 0 and 1. This is the actual particle, okay? So let's go back to the calculator and learn how to do one other thing here. Another method that will become very useful, that perhaps you don't know about yet, let me show you. Okay, we have typed our formula into y1. We wrote up here that we could consider this to be the position at time 0 is 1. So go back to the main screen by hitting second and then quit. Gives you the main screen. Hit second, then quit. Quit is the mode button right next to second. So second, quit. And now what we're going to do is we're going to type. We want to take the formula we have, which is y1. So we need to get the calculator to display y1. Here's what you have to do. You have an 84, you hit the alpha key, and then you're going to hit F4, which is the trace button. You get a list. It doesn't do this on the 83. I'll show you in a second the 83. So on the 84, you hit alpha, F4, and we want y1, so we just select 1, and there it shows up. Raise your hand if you have that, please. Show me. 2 more. Anyone have a question? And then you just hit parentheses. Type in the value of t that you would like to use, which is in this case t equals 0. Close parentheses, press enter, and it calculates it for you. You're going to need that later. Okay, you will need that later. It's the same thing, just a different way. And it just kind of depends on the problem, Soren, honestly. Like I've just seen some problems where it's just a little more convenient to just do nothing. It just kind of depends.
And this is like the function that we typed in.
Into y1.
So if we didn't have a function typed in, we this and use it here.
I'm not sure we could try it. So you could say like alpha, choose number 2. Since I don't have anything in 2, I don't know what it will do.
It just says invalid.
Just invalid.
Okay. How do you find out on the 83?
So on the 83, here's what you do instead. You hit, I gotta remember this.
Yeah, I'm too old.
Sick and old. So you hit the bars key.
Whoa. Right.
This is for the 83 only. Hit the bars key. You got that?
Yeah.
You arrow to y variables. Got that?
Yeah.
You choose 1 per function, and there's the list. The rest of it's the same. Anybody else? Awesome. Okay, so we're going to do another one here. Let's go back to the graph, though, because as Soren said, in this case, the graph's a little easier to kind of follow what's going on. I don't know exactly what time this is right here. I don't think I have a good way of finding exactly what it is at this point. You can see pretty close. A little more than about 0.25 maybe. Let's try that. So let's type in 0.25, see what happens. Pretty close. So somewhere around 0.25. The y coordinate is very, very close to 0. So we'll say 0.25 is a good enough estimate. So let's label that on your picture over here. So you have another dot on the graph right here. And it's not perfect, but we'll say it's good enough for today. So we're going to label this point right here as 0.25 and 0. It's not perfect, but it's good enough. Okay, I want everyone in the room to raise their hand. Please raise your hand and tell me, what does the 2 numbers represent? It's a graph. It's not a picture of the particle's position. It's a graph representing the particle's position. So please, what do the 2 numbers represent? All we know. What do these 2 numbers mean? 0.25 and 0 mean something. In this picture, they mean something. You've got to know how to translate these numbers to this real life situation. Like we could write it up here. 0.25 and 0. It's a bit of an estimate because it's not exactly 0.25, but Good enough for today. All we know, hands up. Okay, everybody knows. What is the minimum?
So 0.25 is the time and position
Nice. How many knew that? 2.3 for Amanda. So somebody, how do I put that information? We've already put the information here and here and here. How do I put that information over here? All we know. Come on, come on. How do I put this representation here? All we know. So Soren,
We can just do t equals 0.25 over the 0.
nicely done. So I say position is 0 now, so the dot has moved. So I'm going to draw another dot just to kind of, actually I guess I should use the same color, green dot. So the dot's here now and the time is different. It's approximately 0.25. How many knew that before Soren said it? 2, 3 for Soren. Questions, please?
And so, like, I get all this stuff, and so I don't know what to call it. Is that just like the distance, like the representation of what it's actually doing?
This one here?
Yeah. So, so it basically is it like saying when it's at? So is that just like a distance of it, like what it's traveling? Like what is that actually represent?
Oh, good.
You know what I'm saying?
Yes, everyone hear the
And
same.
like the time, could that be like seconds, hours, minutes, just depending on the
Yes,
question?
perfect, perfect. Hey, listen, please, listen. Okay, 3 tickets, really good question. Look, the time will vary depending on the problem. Minutes, hours, days, whatever. This doesn't really, listen carefully, this doesn't necessarily show distance traveled. Don't let them fool you on future questions. It simply shows position. Okay? Like at time equals 0, the particle's here at spot number 1. At time equal 0.25, particle's here at spot number 0. Question? Good. Notice, let's go one other place here. Let's go to time equal 1. Let's go back to the calculator, hit trace. Still waiting for, we're just going to type in 1, press enter, -8/3. I'm kind of a fan of decimals, not fractions, but that's kind of up to you.
How do you change it?
I have to remember. Mode maybe? Answers, right here. I want my answers as decimals. I hit the mode button. It may not, I can't remember if the regular 84 does this or not. So I do there and then just go back to the graph.
Yeah, how'd you do that?
Mode. Trace, type in 1. There we go.
Yay.
Please.
How do you do that on the Inspire? Like, given a certain value, what is the?
There's a similar menu choice between like auto versus decimal versus fraction. I just don't remember the menu sequence. So when you have a chance, I can sit with you, can probably find it, or you can poke around and maybe see it. But just don't remember the setting exactly. Anybody else? Awesome. So I can put on the drawing over here. Time equal 1. And this was -2.667. Okay, everyone, please write this exactly as I wrote it. There's a reason. Look at me. Okay, we're using calculators now on the AP test. Any final result that you found using your calculator must be rounded to 3 or more decimals. So we'll just always use 3 to practice. 3 or more decimals correctly. If you do less, you lose points. So I just always do 3. Question. Okay. So put this dot over here. That's at a point of, let's see, 1 comma minus 2.667. Okay, I want, this is true or false. 1 means true, 2 means false. In this picture, I see these 3 dots, and the dots go down and to the right. True or false? Does that mean that the particle's movement was down and to the right? This means true, this means false. Show me your secret vote. in this plot, I see the dots going down and to the right. True or false, does that mean the particle moved down and to the right? 2 points for the room, well done. So somebody, how did the particle actually move? Ellie,
Backwards and then at the mid, it went forward.
nicely done. So what Ellie noticed is that the particle is moving strictly to the left. You can think of it as backwards, doesn't matter. In the AP test, they'll use the word left. So the particle is moving to the left, and then she notices that right here at time equal 2, so that spot, that's 2 comma, somebody have the calculator quick, what's this?
Negative 4.3.
What is it?
Negative 4.3.
So 333. So we'll round it, it's just 333. So the particle started here, it moved left until it got over here to a position of a negative 4.333. That was at a time of 2. Now the particle's position, the y coordinate on this graph becomes less negative, therefore the particle is moving to the right. Show me 1 or 2 if that makes perfect sense. 1 or 2 if it makes perfect sense, how the particle really moves. 1 or 2 if it makes perfect sense. 1 means, yes, it makes perfect sense. 2 means it does not. Sorry, that's confusing, I know. 1 or 2. 2 more tickets for the room. Okay. I don't need to know exactly, but I would like you to find it approximately using your calculator. If you can find it exactly, that's great. But for today, approximate will be good enough. Raise your hand if you can tell me the whole room, please. So the particle started here at a spot of 1. It moves to the left at about 0.25. It hits position 0, goes all the way to position negative 4-ish. Starts coming back. Raise your hand and tell me approximately, it doesn't have to be perfect, but approximately what time does the particle get back to this spot 0? Raise your hand and tell me, this is the origin, is what they'll say in a test question. At what time does the particle get back? Approximately, it doesn't have to be perfect. Just look at the picture, tell me about what time does the particle get back to here? Just about. What time does the particle get back here? Let's go, Tara. Pretty good answer. So are you looking right here, Tara?
Yeah.
Good. So we can hit the calculator and kind of see it a little bit better probably, but that's very good. So I pull this up, I hit trace, kind of drive over here just to get a look at it. Tara said 3.3, we can kind of go quicker. Pretty good guess. Maybe just a tiny bit more, but close enough. So we'll say 3.3 for today, it's just estimating. So I say on my little chart here that, let's see, at time, we figured out that at time 2, the particle was at negative 4.333. Then when we got to about 3.3, the particle was back here at 0. So this coordinate here is about 3.3, 0 roughly. How many knew that before she said it? 2 and then 3 for Tara. Questions? Okay, no homework tonight. It takes a while to kind of get the idea of what we're talking about. Just want to make sure this all makes sense. So day off, it's going to catch up on your test. If I gave you a calculator, make sure you do not take it with you. I will hunt you down. This is great.
Please come to the main office. Grace Carter, Olivia Newsom, Leslie Wyman, and Allie Woodard. Again, I please have Grace Carter, Olivia Newsom, Leslie Wyman, and Allie Woodard.
Well, I would do. It's like the attendance that was at the Orem during. There was. Is there a girl basketball?
Who has my calculator?
I do.
Who else has a calculator?
Oh my God. Guys. Well, babe. I like to I will eat you for dinner. I want to see that. I would like to see that. I would like to see that. I would. It tastes gross. How to fatten your body. Whoa! Isn't fat supposed to be delicious though? No, I think that meat is fat. That's not flavorful. That's disgusting. You're disgusting. Yeah, look at your body. I'm lean meat. Yeah, that's good today. Yeah, you drank tea for days. Why How? I don't even see that.
It was 82.
I just got
And I
your
think
skin.
I got a 79 on
Crazy,
this.
right? You don't even know anything. I was like, yeah, look
Grace
at your
Carter,
body.
Olivia Mitchley, Leslie Robbins, and Abby Walker. Please come to the main office.
Chad.
Grace
Hey, Chad,
Carter, Olivia
question.
Mitchley,
What?
Leslie Robbins, and
You have to be
Ellie
Kate.
Wicker. Sorry about that last name.
Are you
Please
on?
come to the main office.
Are you No, I can help you.
Just gonna sit over there for me.
You and who else? Just you. Well, it's really not one specific leader. Do all my work. I kind of keep on my role. Okay, okay. No, I definitely help.
So Kelsey,